Hi, good morning. My name is Maya Parker, and this is my final presentation for Biochemistry 1050. It is on Chapter 47 of Harper's Illustrated Biochemistry, and it's called The Metabolism of Xenobiotics. Okay. The metabolism of xenobiotics. The word xenobiotic is derived from the Greek prefix xenos, meaning foreign, and suffix biotikos, meaning life. Xenobiotics can be naturally occurring or synthesized, such as medicine, food additives, and pollutants in our environment. Metabolism refers to the transformation of chemicals from one moiety to another by an enzyme. This enzyme is part of a system called the cytochrome P450, or CYP450 for short. Xenobiotic metabolism is generally a detoxification process. However, the metabolism of certain compounds can produce both desirable and undesirable effects. A prodrug is a harmless compound that, when metabolized, turns into a helpful, biologically active compound. A procarcinogen is an inert compound that produces undesirable effects when metabolized. The CYP450 system of enzymes is the most well-known family of enzymes that are involved in xenobiotic metabolism. CYP450 enzymes are mainly oxidases, reductases, and hydrolases. The job of the CYP450 system is mainly to convert lipophilic molecules to hydrophilic products to be excreted in the urine or bile. CYP450 is a heme enzyme. Most CYP450 enzymes are located in the smooth endoplasmic reticulum, mitochondria of hepatocytes, small intestinal epithelia, and some CYP450 can be found in the proximal renal tubules. This is a schematic of the CYP450 enzyme in a hydroxylation mechanism. This is an example reaction catalyzed by CYP450. This is taken from our book, Harper's Illustrated Biochemistry, and it says NADPH cytochrome P450 reductase catalyzes the transfer of electrons from NADPH to CYP450. Reduced CYP450 catalyzes the reductive activation of molecular oxygen, one atom of which becomes a hydroxyl group in the substrate, and the other is reduced to water. Phases of xenobiotic metabolism. Xenobiotics are metabolized through phase 1, phase 2, and phase 3 metabolism using enzymes that are specific to each phase. Sites of xenobiotic metabolism are the liver, the kidney, and the small bowel. This is a figure that is showing a oral medication that is presumably taken by mouth. It is gone into the stomach, brought through the portal system in the liver, and CYP450 enzymes start breaking it down. It breaks it down from a presumably lipophilic molecule to hydrophilic, and it's going to be excreted in the urine via the kidneys or the bile and via small intestine. Phase 1 metabolism is regulated by the cytochrome P450 system of enzymes. The enzymes active during phase 1 metabolize xenobiotics, producing a water-soluble metabolite through reactions involving oxidation, reduction, and hydrolysis. The major reaction involved in hydroxylation catalyzed by monooxygenase of the cytochrome P450 family. In addition to hydroxylation, CYP450 catalyzes a wide range of other reactions such as deamination, dehalogenation, desulfuration, epoxidation, peroxygenation, and reduction. Going back a slide here, during phase 1 metabolism, compounds are rendered more reactive by introducing groups that can be conjugated with glucuronic acid, sulfate, acetate, glutathione, or amino acids in phase 2 metabolism. This process produces polar compounds that are water soluble and can be excreted through the renal system in urine or through the gastrointestinal system via bile through the biliary tracts. Phase 2 metabolism. Phase 2 metabolism conjugates compounds rendered from phase 1 metabolism, with glucuronidation being the most common conjugation reaction in phase 2 metabolism. Phase 2 enzymes transfer an endogenous hydrophilic group that often facilitates the excretion of the molecule from the body. These reactions include glucuronidation, glutathione conjugation, methylation, acetylation, sulfation, and amino acid conjugation. The most common phase 2 xenobiotic metabolizing enzymes are UDP glucuronosyltransferases, sulfotransferases, N-acetyltransferases, glutathione S transferases, thiopurine S methyltransferases, and catechol O methyltransferases. Acetyl-CoA is an important intermediate in phase 2 metabolism. Glutathione, gamma-glutamyl-cysteine is a tripeptide that plays a very important role in phase 2 metabolism. Glutathione forms conjugates that are excreted in urine and bile. The reaction catalyzed by glutathione S transferase is seen below, where R is an electrophilic compound. R is combined with glutathione and produces this product. Metabolism of certain compounds can occur in the kidneys. This phase is referred to as phase 3 metabolism. Phase 3 metabolism uses two molecular transport systems responsible for the uptake and transport of molecules within the cell. Examples here are the ATP binding cassette, which assists in the efflux of xenobiotics inside the cell, and the solute transport carriers transport molecules against an electrochemical gradient. Importance of glutathione. Glutathione is a tripeptide found in many tissues. Glutathione has powerful antioxidant properties which scavenge reactive oxygen species, also termed ROS for short. Glutathione is a tripeptide found in many tissues at relatively high concentrations, similarly to glucose, potassium, and cholesterol, with a critical role in several physiological processes such as redox balance preservation, reduction of oxidative stress through detoxification from xenobiotic and endogenous compounds, and also immune system modulation. Glutathione is crucial in the detoxification process of electrophilic xenobiotics and has powerful antioxidant properties which scavenge reactive oxygen species which are referred to as free radicals. Reactive oxygen species are molecules that contain at least one unpaired electron in their outer orbit. This unpaired electron strips electrons from surrounding molecules, causing molecular degradation or oxidative stress. Here is a schematic of glutathione synthesis and utilization in animals. It is fairly complicated, but I think it gives a decent idea of just how this process works. This schematic looks very similar to many of the schematics that we have been studying throughout this course, including fatty acid synthesis and the utilization of glucose for cellular respiration. Factors affecting xenobiotic metabolism. Metabolism of xenobiotics can be affected by several factors. These include age, gender, presence of disease, and other factors such as solid organ transplantation, medications, and genetic variation of the CYP450 enzymes. Adverse drug reactions are more common in women than men, and this difference may be due to sex hormones, body weight, fat composition, pregnancy, increase or decrease in enzymatic pathways. Bodily changes occur throughout the lifespan, which result in changes in enzyme levels, body composition, and other factors related to xenobiotic metabolism. Infants have a lower expression of CYP450, which can result in decreased ability to metabolize xenobiotics. The elderly may experience a combination of disrupted hepatic blood flow and polypharmacy, which can modify their ability to metabolize drugs. Presence of disease such as cirrhosis, hepatitis, non-alcoholic steatohepatitis, also called NASH for short, and cholecystasis. These all reduce portal blood flow and therefore reduce the ability of the liver to adequately metabolize xenobiotics. NASH is a common liver disease in the United States secondary to the obesity epidemic. Another disease, diabetes mellitus, is secondary to the obesity epidemic, at least diabetes type 2, which is also associated with fatty liver disease, also called NASH. And it also can impair xenobiotic metabolism because it can really decrease your renal function, but as well as your hepatic function. And diabetes affects nearly every single bodily system. So liver transplantation is solid organ transplant, and it can affect all three phases of xenobiotic metabolism. Commonly used immunosuppressants in solid organ transplantation can also alter the bioavailability of xenobiotics. Genetic variations of the CYP450 system can influence drug kinetics, and these are, inhibition and induction. So inhibition works on the enzyme levels by blocking or competing at the site of metabolism. These can be competitive, where the drug binds to the active site, uncompetitive, where the drug binds to the drug enzyme complex, or non-competitive binding of a drug to an allosteric site, and mixed. So an inducers act by increasing the gene transcription, which results in a higher enzyme content. Presence of inhibitors typically increases drug concentration and requires a decrease in the dose of the drug, dosing interval, or both, whereas the inducer has the opposite effect. So abnormal metabolism of a common drug, such as warfarin, can result in life-threatening complications, such as extensive bleeding, which can be hemorrhagic and fatal if not treated. Any mild minor head strike when you're supra anticoagulated can mean death or debilitating injury. So here, this touches again on inhibition and induction, which are genetic variations in the CYP450 system. Again, inhibitors work on the enzyme levels by blocking or competing at the site of metabolism and can be competitive, uncompetitive, or non-competitive. And inducers generally need less of the drug to achieve the desired effect. Inhibitors require more of a drug to achieve the desired effect. So, clinical correlations, why this is important to me. I chose this because I am heading on a nurse anesthetist route, and that means you are inducing anesthesia, loss of consciousness with drugs, and this directly relates to drug metabolism, because that is what it's all about, and how different factors can affect drug metabolism, or the way that the drug effect. Anesthetic agents are exogenous compounds that are referred to as xenobiotics. Most common anesthetic agents are inhaled or intravenous. Sevoflurane is a common inhaled anesthetic agent. Propofol is a very common IV anesthetic. We actually use this a lot for sedation in the surgical trauma ICU that I work at. And ketamine is used for sedation and anesthesia, and we also use it for pain. Anesthetic agents are toxic to the liver and the nervous system. Inhaled anesthetics in particular generate reactive oxygen species and require glutathione as an antioxidant to assist in counteracting their toxicity during metabolism. Now we're brought to some questions here. Which phase of metabolism does glucuronidation occur? Phase 3, phase 1, phase 2, or glucuronidation occurs in a separate process? This would be phase 2. CYP450 polymorphisms can affect xenobiotic metabolism by either inducing or inhibiting xenobiotic metabolism, increasing drug metabolism, decreasing drug metabolism, or all of the above. And the choice here is all of the above. Xenobiotic metabolite toxicity can occur with which comorbidities? Chronic kidney disease, NASH, cirrhosis, and history of small bowel resection. Advanced age, chronic kidney disease and NASH, and infancy with complications of premature birth. And the answer is all of the above, because infants can have a lower expression of CYP450 enzymes, and they gain them as they get older. So premature birth would result in even fewer, and a history of a small bowel resection would remove part of the bowel that is involved in metabolizing drugs. Definition of what is considered a prodrug is a biologically active substance that when metabolized causes harm A drug that when taken concomitantly with another drug produces the desired effect. A drug that when taken concomitantly with another drug produces an undesirable effect. A drug that when metabolized becomes biologically active. And that is the correct answer. Which statement best describes CYP 450 induction and inhibition? Inhibitors can competitively bind to an enzyme. Inducers can act by increasing gene transcription at the enzyme's active site. Presence of inhibitors can increase drug concentrations in the body. And all of the above are true statements. That is true, all of the above. Here's the answer key. And here's the bibliography. There is some really interesting research that I uncovered. Certainly way more than could be addressed in this slideshow. But these are the articles and that I used to create this presentation. It's all very interesting. Okay, thank you for listening.